All right, here we go. In this episode, we're going to see how fast tree sets are compared to array lists. So I've added a little bit of code since the last time. I've got an array list that has a bunch of items that I want to find. There's 1,000 items in it, and it's the same setup of I've got a random number between 0 and 5,000. I've got my starting and ending time all set up. So all I need to do is inside the bracket of starting and ending time, I need to go through and look for each item in the wanted array list. So W in want, and I want to see, let's see, we should keep a count. So count is 0, and then if the tree contains the wanted item, then we'll add 1 to the count. So when I run this, I'm expecting again to find about 200 items, and we'll see how fast it takes. It's important when you're doing your timing that you only time the searching and not the making, because making the items to look for can take a bunch of time in itself, but that's not really fair to count that either for ArrayList or for TreeSet. So let's get this thing going. And down here we see found 186 out of 1,000 items and took 9 milliseconds using this current time millis. Okay, and again, I have found 170 items in 7 milliseconds. So hey, that's like not bad. I mean, it seems pretty fast actually. And 191 in 4 milliseconds. Hey, it's getting faster and faster. So can't argue with success. Let's try one more time though. I'm expecting, here we go, 214 milliseconds. So still, we're right around the 5 to 10 millisecond range for a tree set. Let's try converting this thing to an array list instead of a tree set. So now it's still going to be called tree, sorry, but now when all the items go in, they won't be organized. And then the .contains method for ArrayList just searches every single item until it finds it, or until it gets to the end. So now we're expecting this to take a little bit longer. Okay, prints out the first 10 items in the array list, and you see now they're not in any order at all. And now it's looking and looking and looking. Okay, it still found 199 of them, but it took 10,261 milliseconds instead of 10 milliseconds. So about 1,000 times slower. Let's try this a couple times and see if trying it a couple times speeds it up like it did the last one, but we're not optimistic. Okay, we're waiting for it to finish. And again, 178 out of 1,000 searches in 10,345 milliseconds. So you can see that for this set of data, the array list is a whole lot slower than the tree set. And the reason the array list is so much slower than the tree set is because the tree set organizes the information when you put it in, and then it's very quick to find it because it can do binary search, as opposed to the array list, which is not going to be doing binary search. All right, so that's the end of the speed test.